Oh, good evening, Siddhisri.
Good evening, sir.
Yeah, good evening. Just wait for 2 minutes till everyone joins.
Okay, sir.
Good evening, sir.
Yeah, good evening, Shubhans. Good evening, Dhari. Okay, so in the last class we were doing about eye defects. Today we'll complete the eye defects. So only few of you have joined. Still continuing. Okay, see. Today we'll do about eye defects, myopia, hypermetropia, and presbyopia.
And sir,
Yes.
can we also do about calculating the power and
Yeah, calculating the power. Yes. So that is the only tough part that students find here. Myopia. See, there are different ways to remember. Otherwise, people always get confused between myopia and hypermetropia. So you must have some small tricks, okay, some word acronyms or something so that you can remember them. So myopia, it is also called as nearsightedness. See now everything, all the meaning will come from here. Myopia, and if I write hypermetropia, hypermetropia, it is called farsightedness. Understand the differences. Myopia is a short word. Okay, out of the two words, myopia and hypermetropia, if you observe the word length, okay, the word length of myopia is smaller and the word length of hypermetropia is bigger. Okay, so that is why you can remember it this way, that myopia, it's a short word, so it refers to nearsightedness or short-sightedness. Okay. Now we complete the meaning of nearsightedness or short-sightedness. Nearsightedness or short-sightedness means the nearby objects are visible and far off objects are not visible. So during myopia, you have, if a person is suffering from myopia, the person will be able to view near objects. So near objects are visible, but far objects are not visible. Far objects are not visible. So about the near objects which are visible, we can say myopia being nearsightedness, hypermetropia being farsightedness. Let's see. And how it happens, we'll see both of them. Hypermetropia. So the word is a long, it's a long word. Hypermetropia. The word length is big. So in this way you can remember. However, it does not have any meaning. But yes, you can remember it that way. So hypermetropia is a long word and it is far-sightedness. That means the far objects are visible. Far objects are visible. Nearby objects are not visible. Now see, we need to understand what do we mean by near and far. So near objects are not visible. So try to
Sir,
understand this.
what is the near
Yes.
point of hypermetropia, sir?
Yeah, what happened?
What is the near point of hypermetropia?
Okay, near point. It can be any point up to which the person cannot see. See, for a normal person, if you observe for a normal person, the near point is 25 centimeter. So that means a person can see all the objects which are placed at least a distance of 25 centimeter from the eye. Whereas a person who is having hypermetropia, he will have his near point greater than 25 centimeter. That means a person with myopia, he can see he cannot see the objects placed at 25 centimeter. Maybe he is not able to see the objects up to 30 centimeter. Okay. So this refers to the near point. Near point means the point up to which at which the person is able to see the objects clearly. Understood? So for
So,
normal person, it's 25 centimeter.
so he can see the object which is placed placed near 30 centimeters near point as.
Yeah, see, normal person, he can see the objects at 25 centimeter. But a hypermetropic person, he cannot see the object at 25 centimeter. Maybe he is able to see only up to 30 centimeter. Maybe he is able to see only up to 50 centimeter. He is not able to see the objects between 50 to 0 centimeter. This 0 to 50, it is not his range. He can't observe the objects placed between this. All the
Okay,
objects placed beyond this, he is able to observe. He can see all these objects. But the objects placed between 0 to 50 centimeter, he can't see. Got it? So
okay, sir.
he should be able to observe the objects up to 25 centimeter, but he is not. So this is what we call as hypermetropia. See, far sightedness. He can see beyond 50 centimeter, but he can't see before 50 centimeter. Got it? Yes, is this clear to everyone?
Yes, sir.
Yes. So see,
Yes, sir.
any doubt? Okay. In the same way, we have for myopia. So myopia means short-sightedness or nearsightedness. So in short-sightedness or nearsightedness, again, a person is able to see nearby objects. That means he can see the objects up to 25 centimeter. He can see the objects clearly at 25 centimeter. Okay, so this object is seen clearly with the eye, but the objects which are placed beyond this. So maybe he is able to observe at a certain distance. Suppose he is able to observe up to a distance of 1 meter and he is not able to observe beyond that. So beyond this, his visibility is not clear. Before that, his visibility is clear everywhere. So here we call this as the far point. This is the maximum point up to which the person can see. Got it?
Yes, ma'am.
Yes.
Anyone
Yes, sir.
having any doubts? Okay, just quickly see the diagram and then we will see some questions based on this. Okay, so I hope now you can understand for myopia, if we have our eye lens. So in myopia, the person is able to see nearby objects, but his eyes are not able to observe the far objects. So suppose if you have a ray of light coming from very far off. So the lights which come from far off, they come parallel, and these light rays they meet before the retina. Again, you need to use it some method to remember this. It is myopia, and myopia means nearsightedness. So near means the image is from near. Got it? Nearsightedness or myopia. So it means that the person or the image is formed near the lens. It is formed before the lens. So this situation is represented as myopia. But the person may be able to observe the nearby objects. He is not able to observe far off objects. The light rays which come from far off objects, they come parallel. Now to correct this, one must use a concave lens or a diverging lens, which will diverge the range of light. Okay, it will diverge the range of light a little bit so that a convergent beam will be obtained on the retina. So it will be something like this. If I want to correct it, so we use here a concave lens that will act as a diverging lens over here. A ray of light which comes parallel. So here we have two rays of light which are coming parallel. So these rays of light, they get diverged by it like this. A little bit of diverged, and then after divergence, they can meet on the retina. So in this way, the person will be able to observe the image objects which are placed even at infinity. Got this? Can you observe here? The rays they have become diverged by this lens, and hence forming the image on the retina. Got it,
Yes.
everyone?
Yes, sir.
So for the correction, the lens that we have used is a concave lens, and its power will be negative. Since concave lens has a negative focal length, so the power of this lens will be negative. Now let's see what happens for hypermetropia. This is for myopia. Let's observe for hypermetropia. So okay, see. So for hypermetropia, the person cannot see nearby objects. He can see far off objects, but the nearby objects are not visible to him. So that means if an object is placed at a distance of 25 centimeter, so the ray of light, they do not it is not able to converge on the retina. Rather, the rays of light, they converge after the retina, behind the retina. So here the object is placed at 25 centimeter and the person is not able to see it. So this case is called hypermetropia, far-sightedness. That means far objects are visible clearly. Hypermetropia. To correct this, we'll be using which type of lens will be used? Yeah, Aryan, which type of lens will be used?
Convex.
Convex. Okay. So here we'll be using a convex lens. Since our eye lens needs a help in converging, so we'll be using a convex lens here. We use a convex lens in front of our eye lens. Now this convex lens will converge the light rays. So you will have again from 25 centimeter the ray of light will come, and it gets a little bit converged towards the eye lens, and then eye lens converges is finally on the retina. But so these two diagrams, they show us the correction of myopia and hypermetropia. Correction of hypermetropia. This one is our correction of myopia. Got it? Correction of myopia, correction of hypermetropia. Understood both of it?
Yes, sir.
Now we'll see some questions based on this. Our basic idea today is just to see some questions based on myopia and hypermetropia. So for myopia, yes, so see, a person cannot see objects placed beyond 5 meter. However, he can see near objects clearly. So you have to tell which eye defect is he suffering from. Then you have to also tell, find the power find the focal length and power of lens required. Correction. So try to do this question. Let's think. I'm giving you 2 minutes to think of, and then I will try to. I will solve this. Think of this question.
Sir, the defect is
Yeah. Okay. Did you get the answer? Okay, let's see. So we try to understand which eye defect is he suffering from?
Myopia.
Myopia. Okay. So it is myopia, which we also call as nearsightedness. So he is not able to see far off objects. Okay. This is nearsightedness. He is not able to see far off objects. So for a normal person, what how much distance can the normal person see? Yes. What is the maximum distance that a normal person can see?
Infinity.
Infinity. So whatever lens we use, that lens should be able to show us the objects which are located at infinity. So hence we take here image distance to be infinite, object distance to be infinite. So here object is located at infinity and we want to see that object. We want to see the object which is located at infinity. Okay. Then next we want to see what will be the image distance. We want to find out the image distance. Okay. So image distance V, let us try to understand what should be the image distance. So the person is able to see only up to 5 meters. He cannot see beyond that. So can I say that whatever lens I use here, I should be using a concave lens, I know. So if I use a concave lens, so for an object at infinity, object is located at infinity and it should be able to form the image within 5 meters. It should not go beyond 5. If the image of this is formed between 5 meters, so then our eye lens will be forming its image on the retina. What this lens is doing, this lens is making an image of the object, which image will be observable to our eye lens. So that image will act as an object for the eye lens. Got it? So where should the lens make the image? The lens should make the image at a distance of 5 meters. So image distance should be taken as 5 meters. Now see, this is the direction of going of the rays. So image distance should be taken as -5. Got it, everyone?
1 by f is equal to 1 by v minus 1 by u.
Yeah. So now we can use the formula 1 by f equals 1 by v minus 1 by u. Okay. So we have 1 by f equals 1 by -5 minus 1 by infinite. So 1 by infinite is 0 and hence we have 1 by f equals to minus 1 by 5. So from this you can obtain the focal length of the lens required would be
Minus.
minus 5 meters and the power of the lens. The power of the lens is given as 1 by f. So this should be
100 by
equal to
5.
minus 1 by 5. Yeah. And this would be 0.2, a negative 0.2 diopters. We have already taken it in meter, so no need to multiply it by 100.
Okay. Sir.
Got it?
Yes, sir.
So this is negative 0.2 diopters. Now, in the same way, let's try to do one more question. Okay, is there anyone who has not understood? Okay. Okay, just 1 minute. Okay, so is there anyone who has not understood this? The questions of myopia. So you can understand for myopia, the shortcut can also work. The shortcut is that whatever is given as your far point, that you can take as the focal length. You can take that as the focal length. So now your power as negative. This one. Let's do another one. So now you are given a person can see objects placed beyond 1 meter or beyond 2 meters. Find the eye defect. So which eye defect is he suffering from?
Hypermetropia.
Sir,
Hypermetropia.
sir, hypermetropia.
Okay. So what is the type of the corrective lens?
Concave.
Concave or convex?
Convex.
Convex.
Sir,
So what type of lens is required? And then find its
concave
focal
lens.
length and power. You need to find its focal length and power. Okay, so can you find its focal length and power? Try to solve this question. I'm giving you just 2 minutes to understand the problem, and then I will solve this. Okay, did everyone get the answer? Okay, 2 more questions I have sent in the group. I'll be sharing them also here. First, you solve this. So see, for this one, a person can see objects placed beyond 2 meters So obviously he is suffering from far-sightedness. He can see the objects beyond 2 meters, so he can see distant objects. He is suffering from far-sightedness, but he cannot see objects placed close to eye. That is 25 centimeters. So he cannot see those objects. Find the eye defect he is suffering from. So eye defect he is suffering from is hypermetropia. So this eye defect is hypermetropia. And what type of lens is required? Yes, which type of lens do we require for its correction? Aryan, Siddhisri,
Convex.
convex lens. Yes, so here we require a convex lens. We require a convex lens for its correction. What is its focal length and power? So we want to determine its focal length and power. Now see, the lens that we use, he should make him able to see the objects placed at 25 centimeter. So for this lens, the object distance u should be 25 centimeter. Got this? And whatever image should be found by this lens, that image should be found beyond 2 meter. So the person should be the person is able to see the objects which are placed beyond 2 meter. So the image should be placed beyond 2 meter. So for this one, the image distance should be 2 meter. In centimeter, if I convert, it will be equal to 200 centimeter. So see here we have centimeter, and that is why I also converted this one to centimeter. Now both the object distance and image distance are negative. So I can put this as minus 25 centimeter and this one as minus 200 centimeter. Now we'll use the formula of length. That is 1 by f is equals to 1 by v minus 1 by u. So we have 1 by f equals 1 by v, which is 2, minus 1 by 200 minus 1 by u, which is minus 25. So you can solve this to obtain the focal length, and you should be getting a positive focal length. This is minus 1 over 200 plus 1 by 25. You obtain the LCM. So LCM is 200. You get here 200, and this becomes negative 8 plus 1. So you get negative 7 by 200. So 1 by f is equal to negative 7 by 200, and hence f would be equals to negative 200 by 7 centimeter. Can anyone find the power? What will be the power of lens? Subhansh, can you tell the power of lens required? Sorry, not negative, it's positive. Sorry, I made mistake here. It's positive 8 and negative 1. You should check it. It's positive 8 and negative 1. So you get positive 7. This is positive. So you get this as positive 7 by 100. This is positive 200 by 7. Yeah, Siddhisri? Siddhisri?
Yes, sir.
Okay, Siddhisri, can you tell what will be the power required?
Sir, is it 7 by 2?
7 by?
7 by 2.
Yeah, it will be 7 by 2, which is equal to power you will get as 7 by 2, which is plus 3.5 diopters. Got this? Anyone having any doubts here? Okay, try 2 questions which are given as homework. I have already sent them in the group. Okay, so in the WhatsApp group, you can find 2 questions which are given as homework.
Okay, sir.
Okay, so bye all of you. See you again in next class.
Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir.
Okay, bye. And please all of you join on time so that you can take the complete class.